Hey, welcome back to your favorite trigonometry class. We're going to take a look here today at graphs of the sine, cosine functions, do some transformations with those. So what we're going to do is we're going to first take the sine and we're going to say, we're going to let this be a function. We're going to define f of x to be the sine of x. Okay, so we're going to say f of x equals the sine of x. And you know what we're going to do? We're going to go ahead and let's make a table values here, and let's have some inputs and some outputs. And we're going to use our unit circle to do this, and we're going to find values for the sine and input them on our xy Cartesian coordinate system. So first we're going to put in like 0, right? So we're going to use our unit circle and find the sine, right? We know the sine of 0 is 0. And then we're going to go to pi 6. We're going to find the sine of pi 6 is a half, and so on. So we're going to, let's see, where was it right here? Plug in 0, plug in pi 6, plug in pi fourths, plug in pi thirds, right? We're doing this in radians because this is, remember, radians are, this is just a real number. Radians are unitless. We can't do this, or we don't want to do this with the degrees, right? We just want x, the Cartesian coordinate system, to be a real number. So we plug it in. So we say, all right, what's f of 0? In other words, what's the sine at 0? And we look on our unit circle and we say, well, the y value there is 0. And then we look on our unit circle of pi 6, as I'd mentioned before. Now we take the sine of pi 6. I see that it's a half. So now I'm plugging in pi 6. I find that the sine of pi 6 is a half. So I have the point pi 6 is my input. 1/2 is my output. And then I'm going to plug in pi fourths. So f of pi fourths. So I'm looking for what's the sine of pi fourths. Again, I look on my unit circle and I say the sine of pi fourths is the y value right there, root 2 over 2. And I keep doing this. Pi thirds, f of pi thirds, sine of pi thirds, and I find that that is root 3 over 2. And finally I get to 90 degrees, pi halves, sine of pi halves is 1. So let's go to there, and I'm going to mark my x here. I'm going to go, let me start with pi halves. Let me go by pi here. Pi halves, pi, 3 pi halves, 2 pi, go 2 pi plus another pi halves, 5 pi halves, and so on. I'm going to go 1, 2, so on. Now, pi 6, third the way there, so there's pi 6, pi fourths right there, pi thirds is right there. So at pi 6, we're at a half, so pi 6 comma half. Pi fourths root is root 2 over 2. If you punch in root 2 over 2, and you get, oh, I'm sorry, you get about 0.707 right there. And then punch in root 3. .866, you get that root 3 over 2, you get 0.866. And then finally pi halves comma 1 right there. And I forgot to put in my 0, 0 right there. 0, 0. Okay. So it's kind of going. I didn't draw this the greatest. Pi halves. Now I'm gonna pick some points after pi halves on my unit circle. I'm gonna keep just using my unit circle here. So like, let me go with 2 pi thirds. I'm gonna take the sine of 2 pi thirds. I get root 3 over 2. I'm gonna take the sine of 3 pi fourths. I get root 2 over 2. I'm gonna take the sine of 5 pi sixths. I get a half, and so on. So I'm picking those points. So 2 pi thirds. It's also root 3 over 2, so 0.866. So here's 2 pi thirds right there. And then I'm going to pick 3 pi fourths. And I get root 2 over 2, which was 0.707, if I remember right. And then we had 5 pi 6. We punch in 5 pi 6. We get a half. And finally pi. The sine of pi is 0. Alright, so let me put those on. 2 pi thirds, 3 pi fourths, 5 pi 6, and pi comma 0. Right there. So this is kind of, I'm not doing this the greatest, I'm doing this by hand here. Pi comma 0. Anyways, we keep going with this. And I just continue to pick points. So then I'm going to pick like 7 pi 6. And the sine of 7 pi 6 is negative a half. I'm going to pick 5 pi fourths. You know, you're at 225 degrees if you're looking at that unit circle. And I got negative root 2 over 2. And then I pick 4 pi thirds. Sine of 4 pi thirds, I got negative root 3 over 2. And finally 3 pi halves. If you notice the sine of 3 pi halves, right now you've rotated 3 pi halves are right there, negative 1. And you put those on. Okay, so you got dot, dot, dot. So here's coming down here. I continue. I'm going to graph my sine, graph my sine, graph my sine. You know that the sine at 2 pi, right, if you go all the way around, oh my goodness, sine at 2 pi, right, I go all the way around, sine at 2 pi 0. So right back to here, right? Now we're going to repeat. So once I pick once I get 2 pi plus pi 6, in other words, 13 pi 6, right? If I go around, oops, I go around once to pi 6, so I'm right here again. Sine of 13 pi 6 is a half. So I'm right here, and I keep, whoops, here, and I keep graphing, graphing. Sine of 5 pi halves is 1. That's 2 pi plus pi halves. It's going up. I'm kind of running out of room here, but what this is going to do is going to come down, and at 3 pi, it's going to hit 0. It's going to come down again until I get to 4, or I'm sorry, when I get to 7 pi halves, I got negative 1. So 2 pi plus 3 pi halves. And then it's going to come, oh my goodness, it's going to come back up at 4 pi, it's going to hit again. Okay, so see how right here, and I'm going to try and darken that. So here's called 1 period. And notice that it repeats that after, once I go from 2 pi to 4 pi. All right, repeats that in red. Okay, so this is called 1 revolution. This is your period. In this case, it's 2 pi. Okay, because it repeats that pattern. Now I didn't do any negative values, but plug those in, right? Negative pi 6 sine of negative pi 6, negative a half, negative pi fourths, negative root 2 over 2. Anyways, keep going down to negative pi halves. So again, you're rotating, right? Sine of negative pi halves, you're right here, is negative 1. So it's going to go like that, right? And it's going to hit that point, negative pi halves, negative 1. If I rotate negative pi to right here, now I'm at this point. Sine of negative pi is 0, hitting right there. All right, and it's just going to keep continuing the pattern, right? So it'll repeat that same period, except on that left side from negative 2 pi up to 0. Okay. So this is a graph of the sine function. Notice the domain, we can plug in anything. So our domain is a set of all real numbers. Or you could say x such that x is an element of the real numbers. Right, this is element of course, that's the real numbers. Real numbers. Okay. The range was the highest y value and the lowest y value. Well, the lowest y value is negative 1. Highest y value it ever hits is 1, right? So there's your low, there's your high. Goes from negative 1 to 1. So your range, set of y values, negative 1 to 1, including, so brackets. Or you could say it y such that y is less than or equal to 1, greater than or equal to negative 1, right? If you want to put in set notation there. Notice also the sine function is odd. Like you have this point pi halves 1. If you plug in negative pi halves, you get negative 1. So this is an odd function. In other words, f of negative x is negative f of x, if you remember from your pre-calculus 1 course. Okay, so this is an odd function. It's symmetric. Odd functions are symmetric with respect to the origin. When we say symmetric with respect to origin, that means it flips it around the y-axis to here and then the x-axis to there. That's what it means to be symmetric about the origin. It flips it and then it flips it again. Flips about the y-axis and then the x-axis. So symmetric about the origin. Symmetric about the origin. Notice our intercepts. 0, 0 is an x-intercept. Pi 0 is another intercept, right? Here's our intercepts. 2 pi, comma 0. We could go on. 3 pi, comma 0. Some more intercepts on there. And so on. And you say, where's your maximums? Right, your maximums, you do those in red here. Here's a max, pi halves 1. Here's another max, 5 pi halves, comma 1. Sorry about a little mess here. Here's a minimum down here. Here's a minimum, 3 pi halves, negative 1. Right, the next one, so if this is 3 pi halves, negative 1, the next one would be 2 pi distance away. So in other words, a 7 pi halves, negative 1 would be the next one. Right, because they repeat every 2 pi. So that period. Okay. That's just properties we discussed. All right, so how does y equals 3 sine of x change things? How does that change things up? Well, I'm going to give you a general form of the sine function. We're going to kind of slowly but surely discuss what some of these do. By the way, this is called omega. We'll discuss that later. phi, we'll discuss that later. This is what we're going to change right here. So if you remember from pre-calc, like if you had the function y equals x squared, if you just put a number in front of that, like a 2, and if that number is bigger than 1, what did that do? That was a vertical stretch, right? That was a vertical stretch. Let me erase that. Okay, similarly, with these trig functions, if you put a 3 in front and then you just graph, so let's put 0 in first and let's find it. 3 times the sine of 0. And I say, well, that's 3 times, now what's the sine of 0? Right, I haven't moved anywhere. Right here, the sine of 0 is 0. So it's just 3 times 0, which is 0. So I still have 0, 0. I'm going to jump to pi halves. This is my next one. I could do pi 6. I could do all those too, but I don't want to be super long on this section. So sine of pi halves. So 3 times the sine of pi halves. And I say, well, what's the sine of pi halves? That's 1. So 3 times 1, 3. So spit out 3. So let's plot some points here. I got 0, 0. I'm going to go up by pi halves each time here. So I got 0, 0, but now I got pi halves 3. I'm going to plug pi in now. So 3 sine pi, and we know that the sine of pi is 0, so I get 3 times 0, 0. Now I'm going to plug in 3 pi halves. I know the sine of 3 pi halves is negative 1. Sine of 3 pi halves is negative 1, but I got to multiply by the 3 in front, so I get negative 3. Plug in sine 2 pi, that's 0. 0 times the 3 in front, 0. Okay, so this thing goes... Boy, this thing drives me crazy sometimes. It's going to continue like that, okay. Continue, that's going to hit that. Anyways, we could keep drawing that thing. Now, let me draw the original sine function in red. Here's just the sine function that we just drew. Sine of pi halves was 1. Sine pi is 0. Sine 3 pi halves negative 1. Sine 2 pi is 0. And if I was drawing that, that's what it looked like, right? This was the original sine. So can you see how it vertically stretched that out by a factor of 3? It vertically stretched it. That's what that 3 in front did. Okay? That's what the 3 in front did. And what this A is if the absolute value of A is bigger than 1, it's going to be a vertical stretch. If its absolute value of A is less than 1, then it's a vertical shrink or compression. Kind of flatten it out instead. Okay. Now this is called, that A right there, that's called the amplitude. So amplitude, and it's the absolute value of A. Now formally what the amplitude is, so you can see how it changes the behavior of the graph. It's going to stretch it out or compress it there, depending on if it's bigger or less than 1. The amplitude is half the distance from minimum to max. Half the distance from min to max. So let me do this in black here. So can you see how this goes from 3 to negative 3? Right? This distance is 6, right? But the amplitude's only half of that. So the amplitude is the absolute value of the number, in this case 3, So it's just 3. So it's half the distance from low to high. Okay, but it's the absolute value of that number in front. Okay. Now the domain here, still all real numbers. You can plug anything in. So the domain, negative infinity, positive infinity. Range, on the other hand, it goes as high as 3, as low as negative 3. Okay. Or you could say y such that y is less than or equal to 3, greater than or equal to negative 3. Yeah, that right there means such that, y such that. All right, how about what if we have negative 2 sine of 2x? Okay. So how's this omega change things? Okay. Well, the omega, what the omega does is it changes your period of the function. Changes the period of the function. So if I have y equal a sine omega x, my period, which on the very first one we did was 2 pi, right? And that was because the omega was 1. It was 2 pi. It's 2 pi over whatever omega is. Whatever that coefficient is in front of x, it's 2 pi over that number. I'll tell you what the period is. Okay? And it's really nice when you're picking points to split that period up into fourths when you're looking at the functions and you're graphing these things. Now the negative 2, that negative is going to reflect it about the x-axis. So, and then the 2, the absolute value of that negative 2 is 2, right? So it'll stretch it out. So instead of going up like this to 2, down to negative 2, right? It's going to flip it around. So it'll be like this. Okay? It'll flip it around. And then that number right there, the period will be 2 pi over that 2 right there, omega 2. So your period's only pi. So instead of taking 2 pi to do one revolution, it's this one right here. Okay, forget about the other one. Now it's going to horizontally compress that in. So now it's going to do it in pi amount. So it'll be like this instead. Okay? So that's kind of giving you an idea. I think you'll see it when we start graphing this thing. Let me erase some of this for just a second. And we'll start over graphing this thing. Okay? Alright, so number 1, our amplitude is the absolute value of A. So amplitude is 2. So this is going to be a vertical stretch. And since A is less than 0, it'll be a reflection about the x-axis. Okay? Now, number 2. What's our period? 2 pi over omega. 2 pi over, remember that's our omega right there, 2. So our period is pi. Our period is pi. Okay. Now number 3, I'll talk about a phase shift when we get into a phase shift function, but if we don't have any sort of phase shift, we're just going to start plotting values by splitting with some key points. So we split the period into fourths. Okay, so we're going to start at 0. We're going to end at pi. We're going to split the period into fourths. So, what's a fourth of pi? Well, it's pi fourths. So the next input I'm going to put in is pi fourths. And then what's pi fourths plus pi fourths? 2 pi fourths. In other words, pi halves. What's pi halves plus another pi fourths? 3 pi fourths. And then finally 3 pi fourths plus pi, 4 pi fourths or pi. This will give us one full revolution. And I'm going to plug them in one by one into my graph. Okay. Now I'm kind of running out of room here, so what I'm going to do, let me erase, because I need to have room for my graph, so let me erase some of this here. Let me do the inputs right there. So y equals -2 sine 2x. So I'm plugging in 0 first. And I take, what's the sine of 0? 0. So I get 0, 0. There's my first point on the graph. 0, 0. Now I'm going to get one full revolution just by going out to pi, right? Now I'm going to plug in pi fourths. Well, 2 pi fourths is pi halves. I know the sine of pi halves is 1, so I get -2. Pi fourths, -2. Now I plug pi halves in for x, right? 2 times pi halves is pi. Sine of pi is 0. 0 times that -2 in front, 0. Now I'm plugging in 3 pi fourths. So I got -2 sine 2 times 3 pi fourths, which is 3 pi halves. Sine of 3 pi halves, -1. -1 times that -2 in front, 2. 2. And finally, I take sine, put the 0 in for x again. 2 times 0 is 0. Sine of 0 is 0. 0 times the -2 in front is 0. So this is showing a very nice one revolution. It's just going to repeat that, right? And notice the period was only pi. Period. It only took pi to do that. Yeah. Okay. So that's what that omega does. In this case, the omega horizontally compressed that. Because if that omega is bigger than 1, you're going to have a horizontal compression on that thing. Okay? And of course, that negative flipped it down. So instead of this thing, instead of the sign going up initially, right, it was going down. All right, so how about our cosine function? How about our cosine function? Let me do that one. Let's do that in red. So if we let f of x be the cosine of x, right? And we start plotting a bunch of points. So I'm going to throw in cosine of 0. And now this time, looking on my unit circle, where's that at here? Oops, right here. You know what? Let me stop here. This is getting pretty long. Let me go a second video here. Sorry about that.